Okay, so here we've got the same situation here of our 42 students, mathematics students, geography students, except instead of a Venn diagram, we're going to use a Carnot map or a two-way table or a K-map or a lot of other things. This has a lot of applications elsewhere, not just in probability. I know that it's used in digital electronics because in digital electronics you've got two states. You've either got on or off like a switch, and in this case we've got two states. We've got A can be either A or not A, and B can either be B or not B. So that's kind of how we look at it. So each variable can either have the variable or not. They can either exist or it can't. So how we use it here. Basically, we set up our probability tables like this. So, or a two-way table like this. So we put in our A's and our B's. So A, not A, B, and not B. And then what we do from there is then we follow the B's down, so or the A's across, either way. So follow A across, we end up with the probability of A. We follow not A across, we end up with the probability of not A. So what we should have there is a probability of A, and the probability of not A should add to make 1. Likewise for B. We've got B, the probability of B, not B goes down to the probability of not B, and B plus not B equals 1. Now from there, top left, we've got A intersection with B, or A overlapping B, A overlapping not B, not A overlapping B, and not A overlapping not B. Bit of a mouthful, a little bit of information to take on, but that's the way it looks. Now, we'll take what we've got here, and we'll set up in this kind of table over here. But first, we'll put down this formula. So, A union B is equal to the probability of A plus the probability of B minus the probability of A intersecting with B. Now, likewise, this thing can be transposed. This can all be transposed so that you've got, by taking away the union from both sides and by adding the intersection to both sides. And basically we can just swap those two over. So let's see. So first thing we're going to do is we are going to work out probability of A. Now we know we've got a total of 42 students, and we found before that 30 out of a total of 42 are doing maths methods. So then the probability for that is 30 over 42. That means that there are 12 students who are not doing maths methods. Over here we know that 15 are doing geography, so that means that 15 out of 42, and as a result of that 27 out of 42 are not doing geography. Now we also found out that there was an overlap of 5, so because of that we put in our overlap here, A and B, so that is 5 over 42. Now, we find the rest of these by adding. So, this plus this equals this. This plus this equals this. So that's the way we're going to go through it. So now we've got 5 plus something will equal 30. What does it have to be? Well, it's got to be 25. I said over 32, over 42. And we'll do the same thing, working our way down. So 5 out of 42, we need to make 15 out of 42. So what has to go in the middle? 10. And now from here, we've also got to have 10 out of 42 to 12 over 42. What do we have to have left over? It's got to be 2 over 42. And now this all holds true. If you cast your mind back a few minutes to the previous video where we looked at the Venn diagrams and the information we've got here, 42 students, that's what all of our fractions are out of. 30 students are doing maths methods, 15 doing geography, 10 are doing geography but not maths methods. Now, I forgot to define these, what to explain this before, but hopefully you saw these. Maths methods is A, geography is B, and we've just done that just to keep the continuity there. So 10 students in geography are not in maths methods. So that means we want B and not A. So So we go to B and not A, that gives us this thing. So that's our 10 out of 42. Based on that, we also know we had 2 that were sitting outside of everything, outside of the 2 circles in the Venn diagram. That tells us that there was 2 students that weren't doing either. So not A and not B has got to be 2. And this is how we go off and we do our various calculations that we need to do. It's a handy tool. Put things, as soon as we're dealing with events that aren't mutually exclusive, where they intersect or where they overlap, like we've got here, this is a really handy way of expressing different probabilities.